Right, so we're ready to go. We've got the stacks cleared and now I'm going to start entering numbers. Now there's a different concept too on this. It's not quite the automatic stack that the 15C had. So we've got the stack numbers over here going 1 to 7. Obviously it's a bigger stack, but it's just displaying the up to 7 on the screen. So if I push the number 1 on the keyboard, now what I want to demonstrate is you've got this concept, and I'm calling it a command line. It might be not quite the right terminology. But down here where you've got the kind of arrow flashing, when I've gone and entered that number, it's not yet on the stack. Unlike the 15C, as soon as you go and enter it, just touch a number and it's displayed, it's already automatically placed into the X memory stack. Here it's kind of on the command line. So to get that value or variable onto the stack, we push the enter key. So we go 1, enter. I'm going to do the same. I push 2, enter, 3, enter, 4, enter. So I've got the same numbers as we had previously on the 15C. I could obviously put more in. So now in this case, again, what I can do, the nice thing is you can actually see the numbers in the stack as opposed to kind of imagining them with a single line display. And again, if we go and do the addition, it's very easy to see what's going to happen because we can see the values in the stack this time round. So they've certainly gone a long way, and RPN has become easier to use on a calculator like this. So here we go, we'll push the addition button. 4 plus 3 is 7. Note how everything scrolls down. The 7 plus the 2 is going to be 9. If I push it again, it's going to be 10. But note, unlike that T level stack where there's a constant which is kept down, everything scrolls down and empties the stack. Now what happens is if you, the last item that you've got in the stack, if I push enter again, it copies it. So that can be your handy feature. So as opposed to needing or having that kind of constant, if you need to use a number as a constant, you can fill it in, you can enter it a number of times to obtain a copy. So this is really handy because you can obviously retain a number to use it again. It also means you've got your last result on the screen which you can use for your next arithmetic, and that's the power of RPN. I'm going to show you a little bit of manipulation of the stack before we get down to practical exercise of entering some arithmetic. Right, what I'm going to do again, I'm this time going to fill the stack 1, 2, 3, 4, 5, 6, 7. I'll put one more in just so you can see the stack does continue. Now if you want to navigate the stack, you can use your up arrow over here and you can see the cursor going up, and if I go up you can see I've got, out of the screen was number 8 in the stack level. So you can use this cursor to navigate up and down. If I come down to the bottom over here, the other trick of being able to swap your last 2 entries is on the right cursor over here. It's not denoted anywhere on the 50G. I would have thought they would have done something like a note on here to note that you swap it. But if you look at the 7 and the 8, before I do that, what I need to do is come down to the command line. So I've pushed the enter key so I'm not navigating the stack. And then if I push the right hand cursor, you'll see the order changes between the 7 and the 8. So that's how you go and swap your last 2 entries in the stack. If you do go up into the stack, you can see I've just entered, I'm at the bottom level over here. On the display, you have some options to go and manipulate the stack. I'll bring you in a little closer so you can see the display and the navigation. Right, so you can see I'm at the bottom of the stack here and I can navigate around the stack. Now you've also got a whole lot of options on the menu down here. They continue, in fact if you push the next button they continue off the screen. So this shows you all your options. We come back and if I place the pointer over here and I then pick the roll option like we had on the 15C, you'll see that the numbers below that will roll around. Okay, so they are rolling up. You can see them progressively going up, and then you've got roll down where they'll roll down. So that's how you can kind of roll through and change the order of the numbers in the stack. You can also go and edit a number. So let's say, for instance, I didn't want that to be 5. You've got an edit key here. I can go change that to 55. Push the enter, and you can go and edit numbers in the stack. You can also go and pick a number. So if I go and pick that number, it then goes and replicates it at the bottom of the stack, because I may have a value up here which I've calculated from something before or something I've entered, and I want to use that, and you can go and pick it so you've got it right at the bottom of the stack. And there's other options here as well, but that's a kind of overview of the manipulation of the stack. So the next thing we want to do is show the power of RPN with an actual example. Now, the one big powerful thing about RPN is that it, for one, helps you logically step through an arithmetic problem. It enables you to enter an arithmetic problem with far fewer keystrokes because you don't need to use the parentheses. You work out the things in parentheses like you would as if you're doing it old school on paper. And that's where people perhaps get a bit picky about using RPN, because they're used to having a nice algebraic display on, say, something like this multi-line Texas Instruments, where you can see the whole thing written out algebraically. And I'll come back and I'll highlight perhaps where people may have some point. It'll be up to your kind of point of view. But that is the power of RPN. So I'm going to enter, first of all, do, let's say, a bit of simple arithmetic, and then we're going to enter this more complex expression to see how that's done. Right, so let's go back and do some very basic arithmetic just to get into the swing of things, because there are some critical differences between, as I said, the way this operates, and obviously because of the automatic stack on the 15C. Now, if we go and do this arithmetic again from something like grade 1 or grade 2, as you write it on the paper, so we've got 5, so we'd go 5 and then enter to put it on the stack. We've then got 7, we go 7 and we push the enter button to put it on the stack. So as you can see, just like you'd write it in a stack, as you were using stacks and RPN back in grade 1, we've gone and done that, and then we've got our operation we want to perform. We want to go and add. I push the addition and we get our answer in the first layer of the stack. Now the handy thing is, because it's retained there on a stack in our work area, we can go and use that answer for something else. So let's say now, for instance, we want to, our next problem was to go and do 12 divided by 3. Well, we've already got the answer of 12 on the display, so we don't need to go and enter it. And there's a couple of ways to work with it. I'll show you the kind of most obvious way, and that's to go and say, right, we need 3 on the stack now. So I go 3, enter, and the operation we want to perform is division. So always remember this. You probably wouldn't write division like this. You might do it 12 over 3, or obviously there's other ways of writing it, but nonetheless, just remember the stack. Because when you come to doing complex problems and you've got these 2 answers on the stack and you want to divide, just remember it's just as you see it, as you wrote it. So we've got 12 over 3. We want to divide those 2. We now do divide. Bang, we get our answer as being 4. So that's the one way of doing it. Now let me put 12 back on the stack as we had it. Now the other way of doing it on the 50G, as opposed to going 3 enter and then performing the result of that actual sum, is to go 3 and then just hit the divide. So with it on the command line, I hit divide and that performs operation. So that means there's one less keystroke. And once you know all these things, and that's why people kind of in the know have got used to RPN and they're working out a lot of sums and a lot of arithmetic, using RPN makes things go a lot quicker. There are far fewer keystrokes than having to do what you'd have to do on something like a more modern day algebraic calculator. So as I said, on the 50G, all you need to do is go and perform the operation straight away, as opposed to entering it in the stack unless you want it in the stack. Right, so now that I've shown you that, let's go over to what I want to just show you. Do one piece of simple arithmetic now, because I want you to note my keystrokes. I empty the stack. I'm going to add 1 and 2. Okay, we know the answer is 3. So I go 1, enter. 2, enter, and then the plus and then the answer is 3. Now just remember that, because this is where there's a critical difference obviously on the 15C. So on here I don't have to clear this display, but if you want to know how to clear that, then you've got on your keyboard, you've got something here called CLX, clear X, and that's a shifted function. It's just the blue button or G, and that will clear the kind of X on the display line. So here what we're going to do, I'm going to go 1, enter, as I did on the 50G, 2, enter, and then plus. We'd expect the answer to be 3, however, the answer is 4. Now, if you've kind of followed the logic, you'll understand, remember that I shouldn't have pushed enter on the 2 because that was automatically on already an X. By pushing enter, I merely added it to the stack. And that's why I had the 2 wrong. I had the 2 already on there. So it added 2 to 2 because I just replicated X off the X stack and the display. So on this calculator, if I want to do that, I would just go 1, enter, 2, and then plus. So very similar to what you can do on the 50G, where you don't have to go and enter to reduce the number of keystrokes. That's what you do, and that's why it's important to understand the kind of automatic loading of the stack on the 15C, because those keystrokes, as I say, are different between the two machines. Now I'm going to resort to using the very basic 15C to go and work out this piece of arithmetic over here. I'll first do it on this calculator, the TI-36X Pro. I've also recently acquired this. As I said, this is an update from the other basic scientific Texas Instruments that I've got. But this machine, compared to, let's say, the advanced graphing calculators, might be able to do a lot. It can do a lot of what they can do, but just without the graphing, and it might be a serious consideration. So I'll look at this at some stage as well. Right, so let's enter the problem. Right, we're ready to go. Now we'll highlight, and this is one I think this is a great calculator, but I don't know why Texas Instruments, what they did with the kind of operational keys on the side here, they made them a kind of silver metallic color. And they've got the operational signs on there, but you can see they didn't color them at all. They just left them as kind of indentations on the keyboard. So it's actually rather difficult to see. It's really silly in my opinion, and in fact I might carefully try and actually color them in so that they're easier to see nonetheless. Right, so let's go and enter this piece of arithmetic, and the thing to note here, I'm going to enter it properly as it should be, because obviously we need to note, even though I don't have parentheses around the numerator over here, correctly speaking I need to do it so that we get the right answer. So on here we start off, I've got to enter parentheses, and we go 2 pi squared minus 17. I have to close. Then we have to obviously do the thing to get the numerator, 5 plus, and then we're going to say the square root, which is a second function of 11. We then have to tap out to come to the side to go plus, and then we need our parentheses again, 13, divide by 2.5, close parentheses, and that is multiplied by 7. So there's a fair few keystrokes you have to enter in there to get your whole algebraic format onto the display. But there you go, we've got it in. And if I push the enter button at the bottom here, we get our answer of 36.7293, which I've got noted over here. So let's go and do that same thing on the 15C. Right, so on the 15C, the approach is what we do is we chop it up into small pieces. We work out the individual arithmetic as you'd approach it using your kind of maths order correctly, where you'd use parentheses. So that's where people would look at this and see it as a chore, but compared to, let's say, a normal calculator of the day where you didn't have a memory stack and you just had to go to add up and do individual parts, that's what you would do anyway, but you wouldn't have the power of obviously the stack and RPN. So let's go ahead. I obviously don't need to clear this. All I need to start off doing is actually by working out the actual maths. So our first piece of arithmetic is obviously 2. I enter that. I've then got a second function to get pi. There's pi. I then want to square that, so I simply got a second function and I square it. I've got the 2 on the stack, remember, so I just go multiply to get my multiplication. And I then want to subtract 17, so I simply go 17 minus. I now have the answer for the top part of the problem over there. And remember, that's automatically now saved in X on the X stack in the display. So now I can start with the next part of the problem. I just simply go, we want 5, enter. We then got 11 that we want the square root of, so I enter 11 and then go square root over here. You can see it says square root of X. I have the answer to that. I've obviously already got 5 on the stack above, so I just go hit the plus key to do the addition. And now I've already got the answer to the top of the problem on the stack, and I need to do the division, that divided by that, and I've got the answer. So all I need to hit here is divide, and I get that part of the problem. Now we move on to the next part of the problem over here, which is what we've got in the parentheses. So remember, this also is good maths training because you're doing this according to the order that you should know in terms of mathematical order and operations. So now we're going to do this set of parentheses or brackets. We're going to go 13, enter, 2.5 divide. We get the answer. The next thing we obviously need to multiply by 7. So we just go 7 times. So I've got that answer, and I've obviously got the previous answer still in the stack. So all I need to do push is plus. And look what we get. 36.7294, which is basically our answer over here, obviously rounded. So there's a little bit more mind work involved here in terms of understanding the fundamentals of maths and what you've got to work through than kind of blindly entering it on with an algebraic calculator. But once you get your head around first of all, the actual functional working of a stack, and then understanding that you've got to obviously use your functional maths correctly, RPN is far fewer keystrokes and can get you to a result far quicker. Let's just do that on the 50G to see the kind of how that is displayed on the stacks there. Right, so let's start. We need obviously 2, enter. Then it's a second function to get to pi. That we want to square, so it's another second function, and it's the square over there. That we need to multiply. Then we want to subtract 17, so we go 17 and I simply hit the subtract button. Then we've got the numerator over here, we've got 5, enter, put that on the stack. We then got 11, we want the square root of, which is over here. And we are adding those, so now I just simply push the plus. As you can see, it used a plus, we've added those. We've now got, as you can see, the 2 results on the stack. We can physically see them. And now we simply push the divide key to get that. We then go to over here and we're going to go 13, enter on the stack, 2.5 divide to get that result. That we need to multiply by 7, so it's simply 7, the multiplication button, times. We've now got our 2 parts of the kind of maths, which we need to add, and we push plus, and as you can see, we then come out to our correct answer. So again, so now when you progress to something like the 50G, it's quite nice to be able to see that so that you don't have to use your kind of mind's eye as you do with the 15C. But nonetheless, it's still very doable once you've done it a few times on the 15C. There's nothing wrong with the 15C. Nice, small, compact, very nice keyboard to use as well. So let's just highlight perhaps one challenge with this approach. Let's say I'm working with an equation this is an equation to, I don't know, work out the free space in a ball or something. And I've got certain variables and I want to go and kind of recalculate. Let's say one of my variables changes, like the 17 over here changes to a 22. Well, there arguably then a calculator like this, like the TI-36 Pro or an algebraic multi-line where you've got your displayed or math view display, I can simply go up to the sum. I can kind of enter it again, so I get it down onto command line. I can simply cursor along. To that 17. I can go and backspace it or delete it. I didn't delete correctly there, but I can go and enter 22. I need to close the parentheses, push the enter key, and I get a new result straight away. So that certainly is an argument. I'm sure people who are adept at RPN may challenge that, but certainly if you are working with a complex function or piece of arithmetic like this and you need to go and make a single change like that, that's where something like a calculator like this in the algebraic format are really, really handy. It doesn't mean to say on the 50G that you can't do that, because you can enter things in an algebraic mode here and enter them literally like that as well and do the same thing. But if you are working in RPN, then arguably that might be one of the downsides to RPN. But anyway, I hope that's given you a good understanding of that. And I say, if you are keen to see further reviews of how the 15C or in particular how the 12C operate, this little device, certainly for doing financial work and understanding the value of money, again, makes it very easy, which is why it's still very popular today. Right, so I hope you found that useful. As I say, once you have an RPN calculator like this, if you are kind of seriously contemplating getting into it, it's not too difficult to kind of get used to once you've started using it for a while. As I said, if you do want to support what I do, these calculators, certainly the modern versions, will also be available in my Amazon store, and the link will be down below. If you would like to have a closer look at these in terms of how they function and what they can do, then certainly post a note and I'll do that as well. But if you gain any value, then please give us a thumbs up and share the video, and I'll catch you soon for the next one. Cheers.